Okay, standard form, section 2.2, page 22. Standard form, you may recall from Key Stage 3 if you did level 8, involves writing very large numbers in a short way, in a shorthand way rather, or very, very, very small numbers with many, many decimal places like 0.0000073 or 4 as a standard form number in a shorthand form. There are agreed ways of doing it. There's no opinion about how to do this. There's just set ways you have to flow with. So jumping straight into question 1A, it says I've got to write 3,700 in standard form. Well, somebody may write 37 times 10 to the power of 2. Well, that's disallowed because the complete and accepted answer is 3.7 times 10 to the power of 3. As you can see, starting from here, you allow the first integer, then you count 1, 2, 3. It's 3.7 times 10 to the power of 3. Better change to yellow because it's not as visible, is it? Alright, so let me just show the jumps. Doing, doing, doing. There you go. That's standard form. That is not. It's part of your working if you want to show it, but you can just jump straight in and get it right there. Right, working with yellow. Next one, I've got 2, 3 followed by 6 zeros. 1, 2, 3, 4, 5, 6. Well, there's a 10 to the power of 6 straight away, plus this extra one as well. So I've got 1, 2, 3, 4, 5, 6, 7. That's 2.3 times 10 to the power of 7. Beautiful, isn't it? Sometimes grade B is so easy. Right, we'll try this one now. 200200. Don't be confused by it. Starting from here, we go 1, 2, 3, 4, 5. So it's 2.002 times 10 to the power of 5. Now I know the temptation is to forget about that 2 because it's so far away from the decimal place, from the decimal point rather, but you can't do that, otherwise you're leaving out 200 as part of that answer and you can't do that. So let's just check again. Multiply by 10 and 10 and 10 and 10 and 10 again. That's 10 to the power of 5. So that's also correct. Now when you working with numbers such as this, 0.13, you must still call it 1.3, and this time the power is, go back 1, power of minus 1. Is that alright? Again, the minus 1 isn't actually a negative 1, it's a symbol meaning divide by 10, because you may recall from the previous video that 10 to the power of minus 1 means 1/10. Alright? So if I multiply 1.3 by a tenth, I will effectively take this decimal point and go back that way and become 0.13. Again, you just think on that in your own time. I've got 0.005, so that's easy. It'll be 5 times 10 to the power of 1, 2, 3, going backwards. So it's negative 3. Alright? That one's just way too big to write down, takes too long. I'll do this one. 0.00000, how many zeros is that? 6, 0, then it goes 1, 7, 8. Well, first we write down our 1.78 times 10 to the power of. Now we're going to start worrying about how many times we're going to the left now. So starting from the point here, we go back once, twice, 3, 4, 5, 6, 7 times. That's negative 7. So that's standard form. That's perfectly correct. Moving on to the next page and moving on to question 2. It says write the following standard index form numbers as ordinary numbers. So we're going the other way now. The first one is 7 times 10 to the power of 3. Well, that means 7 times 10 times 10 times 10, 7,000. Very easy. Next one, I've got 7.6635 times 10 to the power of 1. Well, that just means multiply it by 10, move it over, so 76.635, and don't forget to put in your 3 5s because that's all part of the original number. Then I've got this one, 7.0 times 10 to the power of 3. Well, that just means multiply by 10, 10, 10, so that's going to be 7,000. Okay, just check it. 1, 2, 3, yep, that's 3 places. I've got 4.2 times 10 to the power of 4. Let me write my 42 for now. So I'm going to go once, 2, 3, 4. Check it again. 1, 2, 3, 4. That works. 42,000. That's correct. Let's just try one of these. So 3 times 10 to the power of -1. So you take your 3 and go back one place. Alright? So we've got 0.3. We'll try this one. 1.25 times 10 to the power of -3. So let's just take our 1, 2, 5. Take the point and go back 3 places. 1, 2, 3. Now we put our point. Alright? Just study that. Now, that's our answer. Let's just check it. So we're starting from 1.25. Go back once, twice, 3 times. Yep, that works. Definitely correct. 0.00125. I think I'll try the next one. Make this the last one. 3.086 times 10 to the power of -4. Let's write down my 3086. Go back 4 places. So starting from here, 1, 2, 3, 4. Now put the point. So we have 0.0003806. Let's just check it. 1, 2, 3, 4. Yep, that definitely works. So that is the actual proper number, the genuine number, ordinary number for this standard index form notation. So I